Okay. Second shooting session.
Maybe I can start. So a question to Andrea about it sounds more, not so much, maybe a bit different use of the balance of plant. I think you more broadly meant the powertrain optimization. In that regard, do you see, so one of the, I think, big dichotomies happening now in the fuel cell area is the split between the folks who prefer to do pressurized fuel cell stack and those who prefer to use basically a simple blower, more reliable and so on, but then sacrificing stack level power densities. Do you have, from the analysis you're doing, I often hear both sides and both arguments sound very compelling. From your analysis, is there a clear winner? And if there's some, do you have any perspectives on that specific dichotomy?
Okay, so already activated. So thank you for your question, very nice. Well, actually, we do not have yet an answer for sure, because as you said, there are two different points of views. Actually, I think that most of the cars, actually, I think all of the cars that are available, passenger cars that are available now in the markets, they have a compressor and they pressurize the stack at high power or high current density at least to have a sufficiently high power density in the stack. Well, I think that the target or the trend is to try to remove this compressor and to transform it into a blower, but so far it is not possible, I think, because of oxygen transport limitations that we have, for sure, in a car. Well, I think that there is a margin to have the compressor, maybe with a turbo expander, electrical driven, that could be quite efficient, I think. I think this is the best option and would not require very high demanding results from the fuel cell materials. So we do not have to change the characteristic of the electrodes, the properties of the gas diffusion layer, the flow field and so on, in order to achieve such a high power density at low pressure. But I think there are two different roads to achieve these results.
Yeah, can I ask a follow-up question? So the one question I had is also, when you look at this interplay between balance of plant components and the fuel cell stack, is that all based on sort of maps of, let's say, a compressor map or a humidifier map, or do you get actual data from a system somewhere?
Yes, actually, I would say that most of the components are reproduced by a physical model where we deal with a size of a pipe, with a size of a membrane, we have a transfer coefficient, we have convective coefficients and so on. Most of it is based on this, as far as we can validate such models. For, components that are not that relevant or we are not facing in the project, for example, the hydrogen recirculation systems, I think this one probably will be kind of simplified in approach. Anyway, our modeling approach is to have a very high computing model, but very detailed. So trying to avoid using maps, but instead having a real dynamic response coming from a volume being filled by a gas and so on. Yes.
Okay, and then the other thing is that, at General Motors 10 years ago, they built a fuel cell car without a battery, right? That was our task. We had to build it without a battery. And of course, that works very well dynamically. But the fuel cell dies very quickly.
Yes.
And so the battery function, right, to my understanding, is really largely due to minimizing strong fluctuations of voltage or of load on the fuel cell, right? So how would you sort of incorporate in the model the durability effect of the hybridization with a battery, rather than sort of, you can, in the power maximization or performance maximization, it doesn't make so much difference, I think. It's mostly in the durability.
Yes.
And the question is how...
Yes, you are perfectly right. Actually, I would say that in a long-term vision, we will include also the gradation models in our complex model. But I'm not sure that Amedeo will be able to do this in 3 years anyway. But nevertheless, I think as a first start, we do know that there are some limits in operating conditions of the cell. So, for example, people do not operate, automotive manufacturers do not operate stacks with the single cell voltage higher than 0.88, 85 volt in order to avoid degradation. So we will not consider to have the capability to work over this voltage. Or the same, for example, for temperature. We could consider to avoid having the coolant having a temperature higher than whatever degree C. And this will be implemented with the control algorithm in Simulink software or whatever. Probably Simulink, yes.
And can I ask a last question? And
it's an honor for me, yes.
The expander, right? So when I was at General Motors, we always had every year a new review of the architecture of a fuel cell system. And the conclusion was always, well, if we had an expander, a turbo expander, it would be the best system you could possibly build. And so that happened for the 10 years I was there, every year. We, of course, never got the expander. And from what I understand is that the big challenge is, because it doesn't have to go over a large range of flows, it only has to be over the, let's say, a factor of 2. But the problem, as I understood, was always the droplets. So that you had a turbo expander and you have droplets in the flow, and your expander wouldn't like this. So is there any sort of efforts to look into, maybe it's someone else, into turbo expanders which can actually handle droplets, two-phase flow? Because that, of course, would be a big boost for fuel cell system design if one had this. I don't know it exists.
Yeah, no, I think the best would be to remove the liquid. Yes, for sure. Yes, I think this should be the other way around. So in the humidifier, in the external humidifier, to recover as much water as possible. This is the point, but I'm not the guy expert on turbo machinery, so I can say we will check. Thank you for your suggestion.
Let me know if you find one.
I have a question to Roberto. When you try to charge the batteries with in the megawatt range, that means you will have to remove heat in the 100 kilowatt range. How can this be done from a battery that is so closely packed?
We do not deal with the thermal aspect of a battery. We deal about the electrical part, that is about the converter, the electronic converters, and the whole charger. But we are not interested, and it's not our job to analyze the thermal aspect of a battery.
Yeah, but what? How do you value then your work if it turns out that finally the whole system is limited by the thermal transport and not by the electricity?
No, I didn't catch.
How do you value the work then finally if it turns out that everything is limited by the thermal transport and not by the electrical? I don't know, but it's possible that it turns out that you can't remove more than 50 kilowatts from such a battery. And then what does it make sense to try to bring in 2 megawatts if you can't remove the heat?
2 megawatt means that, for example, in a motorway, you have several chargers that must charge several electric vehicles at the same time. In this case, we mean a high power. And if you...
Thank you.
Yeah, I have a question for Roberto Perini, to maybe similar, a little bit general. Because of course, I think that the project is very important. It's easy to understand why smart and fast charging will be very, very relevant in the future. I was wondering if in the PhD thesis, the balance will be more on designing a smart and intelligent system that can understand what is going to recharge and so to optimize and to, let me say, adapt to the system, to the interface, also involve an important part of, let me say, the hardware. So I think that your reference to the wireless charger, so if there is also some consideration about the changing in the hardware system or so.
But the PhD relies not on a wireless charger. The wireless is a side study, the PhD relies on a DC connection, and on the DC connection, and relies on, above all, the impact on the grid by considering several charging profiles, because batteries can be in different operating conditions when they get charged. And for this reason, one of the results that has been obtained up to now states out that even if the design power of the ultra-fast charging system is 2 megawatts, the maximum power that can be drawn at a given time is much less. It may be 60–70%. Then, even if everything has been designed for charging so many electric vehicles at a time whose rated power is summed up 2 megawatts, then it can be found that the system can be designed for a smaller power. But we will deal, above all, on the impact of the grid and on some algorithms for charging the electric vehicle. Then the target is, if it is possible, to study also a converter, but I do not know if we will get to that target.
Clear. It's more on the, let me say, the software part. Okay.
Yes, only 3 years, not...
I would like to ask to, especially you, industrial guys, how much are you actually trying to learn or even develop in-house global methodologies as the one that we have been exposed? I mean, the risk and resilience analysis, the overall system analysis, because in the morning we were all acknowledging the complexity, the multi-scale aspects, but then I see that sometimes there is some resistance when it is a matter of picking up the model, the approach. So what's your personal comment or, I mean, approach in...
Yes, I could start. We attempt to do this, the kind of analysis that you've described, Emilio. We attempt to do this kind of analysis or be participants in those, or at least aware of them. So I've presented a snapshot of what we attempted to do on some of the stuff, and I admit I don't know enough about, this particular analysis, and perhaps even our in-house analysis at the level of details to compare them. But this sounds like a very comprehensive approach. I did have a question about, there's some of the factors in these analyses are regional as related to, for example, the definition of the land usage and so on, right? So the European directive, there isn't a direct equivalent of that, let's say, in the US. So to what degree do you account for those kind of regional differences in your analysis?
Okay. Yeah, sorry, my digital divide confirms, is confirmed again. Thank you for your question, and indeed it's quite relevant. Let me say, without going too much into the details, that the starting point of the larger scale, because the two layer, the technical transport layer and the energy modeling layer are quite more common. When we jump up to the scale, the approach that we use is that of relying on a set of standard database that are analyzed by international community and are standardized. So you have more or less the sector divided, let's say the national economy divided into sectors, and then you have the connection between the different national economy. According to the different databases, there are differences, but this is the detail. And what you have is the country by country and sector by sector. Then you have the amount of resources, land occupation and things like that, that are currently consumed by that sector. And then on top of that, you can use the national or regional, European regulation to set up some constraint about the use of that resources. So you can really, because you have country by country, so you can set up appropriate policy that are coherent with the current situation.
Yeah, as you know, well, at least up to now, the electrical mobility is not our focus in business. We are energy producer and distributor, so we have models trying to optimize the distribution, the production, to shape the peak, to integrate with renewables. What we are trying to use and optimize this kind of model, I think that the project presented by Emanuela could be very interesting, is to match this optimization with the impact on the general decarbonization. So how this is connecting, because this already impacts very much on our business. We have set important decarbonization targets, and of course, as far as energy production and transportation, this is a very good connection. So, of course, we are working especially on these directions.
We are working with the circular economy people of ENI.
But I feel like I a little bit avoided your question, Alessandra, about, do we just do this analysis to gratify us with definition of how difficult is the task and complex, or do we actually converge? Sometimes we do converge. Those are the analysis that drive our investment decisions. And so our choices of internal investments, and most recently, because we were catching up quickly to electrification, external investments are very much driven by these analyses. And so the investment, for example, like I mentioned, we've just bought Hydrogenics. It's a close to $300 million investment. It came out of the analysis like this, right? So those are the bets we're placing now. Does anyone know which one of those bets will be commercially truly successful, and to what degree? I think it would be very difficult to predict today, but at least the choice of the few bets is driven by these exact analyses. So we call them goalpost analysis, and then they megatrends, then goalposts. So it's a similar layered structure.
Interesting. Okay. Other questions? Final.
Oops, sorry. I would have one question to Emanuela, because I saw on your slides also life cycle analysis, right, which is also part of the work. And we recently had collaborated with some other group on life cycle analysis on PEM electrolyzers, right? And so we were just providing data, and they were doing the life cycle analysis. But then the question we ran into was like, you look at the bill of materials which you have in the electrolyzer, and you say, okay, so and so much CO2 is released for mining of iridium and so on. But what we then found was that most of the databases are from the 1980s, when there was absolutely no renewable energy. And then now when you say, okay, I want to make a prediction for 2050, and let me take a reasonable assumption and say at least 50% of the energy is renewable, then all of the databases don't work anymore, right? Because then I have much less CO2 in the production of stainless steel or whatever. How does one consider this? Do you guys do something on these databases, or is there a community which does this?
We are not using that database because we are going back to the original statistical data that are behind the database, so we use the raw data, and so that the raw data are nowadays updated, and it's enough to use the data. It's a bit of matrix algebra behind, but then you can obtain the CO2 embedded or the water embedded, which means the virtual water and everything, which is mostly likely the same results that you obtain with CIMAPRO, with all these databases that are not yet updated. So we go back to the mathematical part of the story, and we use the database that they are not updated, let me say, on a yearly basis, but they are updated every 2-3 years. It depends on the different database, but these are updated because they belong to the statistical data of any national economy. So we change the approach. We don't use the database.
When I want to say, let's say, I make a construction, I need stainless steel. And so I say, okay, I need the CO2 footprint of stainless steel, but for the year 2050. Where maybe in stainless steel, I make the stainless steel by the reduction of hydrogen or whatever, right? How do I do this?
Now you are speaking about the projection. Yeah. Okay, we are working, and Matteo Vincenzo Rocco, who is a colleague of mine, this year received an award about the Leontief prize, because we are trying to set up a model that are taking these static metrics and trying to launch a dynamic approach to these kind of things. It's not easy because it requires a kind of loop between the data that you have and the kind of investment that are expected to be obtained in year by year. So you obtain, big calculation, but there are ways and strategy for approaching a kind of dynamic, let me say, evaluation of these things.
Which you could then project.
Yeah, you can then project. It's not easy. You have to do a lot of assumption and a lot of understanding of how the national economy works and how they will be working, but it's something that might be done.
Okay, thank you. I really thanks the colleagues. Thank you.